Hey boys and girls, welcome back to another edition of Crush Lusher Television. Alright, what we're going to do is we're going to do the answers to the Friday quiz. So this is a Friday quiz for our free response work we've been doing. And so let's go over the answers A, B, C, and D. Alright, so first, let's read the problem. That's what we got to do. So f be continuous, alright, define a negative 4 to 3. Well, it should be negative 3 to 4. That's actually not right. This domain is not right. We need to fix that, sorry. Consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function given by g of x equals the integral between negative 1 and x of f of t dt. All right, and we're going to do all this fun stuff with our picture. And this is the graph of f right there. All right, no problemo. Let's look at my wonderful recreation of it. So graph of f right there. So first thing I'm going to do is I'm going to write my chart. So if g is the area under the curve, the integral, so that means I need to find the derivative of both. So g prime, so the derivative of this side, I need to find the derivative of this side, and the derivative of an integral are opposites, and so the x just goes here, and so that's just the graph. So if I'm looking for the derivative of g, I'm just looking at the graph itself. And then g double prime of x, so find the derivative of this side, I can find the derivative of this side is the slope of the graph right there. So I'm looking at, talking about the concavity or anything like that of g, I'm just looking at the slope of the graph right here. So I'm just orienting myself around this, because this is my little key, and I'm going to make sure that I look at this every single problem. Alright, A, g of 2. So g of 2, I'm going to look up here, so that's going to be plugging in here, so that's going to be the area between negative 1 and 2 of f of t dt. Why is it t and not x? Well, it's just a different variable, so it just could be a different value, that's why. The t is just arbitrary, it could be a, it could be b, whatever. Could be smiley face, whatever. So now I'm finding the area between negative 1 and 2. That's what I have to do. Okay. So negative 1, where the hell is that? Oh, it's here. This is negative 1, 0, because it says that the semicircle is centered at the origin. So if it's 1 this way, it means it has to be 1 this way. So that's a negative 1, 0. And so here is the area from negative 1 to 0, sorry, negative 1 to 1, and then from 1 to 2, we have this little triangle right here. So that's the area I need to find. So this is going to be negative area, that's going to be positive area, because this part is below the axis, this part is above. So it's going to be negative pi r squared. What's the radius of this? Radius is 1 divided by 2. Why am I dividing by 2? Because I got a semicircle. Why is it negative? Because the area is below the x-axis. Plus 1/2, this is a triangle, base 1 to 2, which is 1, times the height, which is the y value, which is 3. Cool. And that's an acceptable answer right there if you want for g of 2. Or you can clean it up a little bit, negative pi over 2 plus 3 over 2. Or 3 minus pi over 2 if you're feeling fancy. There we go. Alright, g of negative 2 now. Oh, so g of negative 2 now, so I'm still in part A. G of negative 2. So that's going to be the area between negative 1 and negative 2 of f of t dt. And I noticed what? Ooh, that my upper and lower limits are needing to be switched. And so I need to have the smaller limit on the bottom and the bigger limit on the top, my upper limit, f of t dt. And so that just makes my area negative. So, negative 1 and 2. What? They don't even have 2 here. Negative 3, negative 1. So I'm just kind of going in between. So negative 2 would be here, right? So negative 3, negative 2, negative 1. I can use my just patterns. And then I have negative 1 and 0. So what's in between negative 1 and 0? Because negative 2 is between negative 3 and negative 1. That would be negative 1/2, right? So negative 1/2 is your y. So it's negative 2, negative 1/2. So it's this little triangle right there. So that's negative, because I flipped the upper and lower limits, And the area here is also going to be negative because it's below the axis. So that's negative 1/2 times the base, which is negative 2 to negative 1, which is 1, times the height, which is 1/2. Bam. So negative times negative, which actually makes it a positive. So since it's below the axis, and then it's negative because I flipped the upper and lower limits, so it's actually going to be positive answer. So it's 1/2 times 1 times 1/2, which is 1/4. Bam. A, done. Thank you very little. B, I want G prime of 3. So G prime, go back to my little chart. G prime of 3 is just F of 3. That's the same thing. F of 3. So F of 3, is this point right here. So this point here, so 2 and 4, so 3 would be between there. And what's between 3 and 1 on the y? That would be, 2. So that would mean that when x is 3, y is 2. Cool. All right, now I got G double prime of 3. So what's that mean? That means the slope. So G double prime means the slope of f. So we need to find the slope. Okay. So the 2 points, you use any of these, 2, 3, and 4, 1. 2, 3, 4, 1, na 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 na. So the slope is negative 2 over 2, which is negative 1. Cool. So part B, done. C, we're going to talk about the horizontal tangents. So horizontal tangents is when the slope of G equals 0. So slope of G when this equals 0. So that just means when the graph equals 0. So that would be here, here. So it's these 2 points right here where the graph equals 0. So there is a horizontal tangent line, of G at x equals negative 1 and x equals 1. At x equals negative 1. All right, so now I got to talk about whether it's relative min, relative max, etc. So I'm looking here. So this slope so this is, I'm just looking at the actual graph. So this is actually negative, 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 negative. So this is down, 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 pause, down, 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 up, 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 up. Because the graph is actually the derivative right there. So I talk about going up and down like that spider. Remember where the monkey going up and down the vine? We talked about before. So x equals 1. There is neither a min nor a max because G prime of x doesn't change from positive to negative or negative to positive, or you can say change signs. Okay. At x equals positive 1, you're going from negative to positive. So negative to positive, negative to positive. So that means it's going to be a minimum. At x equals 1, there is a relative minimum because f of x changes from negative to positive. Cool. Yeah, you can say G prime of x or f of x, they're equal, it's the same thing, and so no matter what you have, that is acceptable. Okay? So, part C. Are we almost done? Yeah, we are. Part D, points of inflection. So points of inflection are always with the second derivative here, and the second derivative is just the slope. So when does the slope change from positive to negative or negative to positive? Well, here we have positive slope, negative slope. So it's here, negative 1, 0, and 2. That's where we change. So, part D, there are points of inflection at x equals -1, 0, and 2. -1, 0, and 2. Because f prime of x, the slope of this, changes from increasing, so increasing, to decreasing, or decreasing to increasing, or vice versa, you could say. Oh, there you go. And there's my 100% on my quiz. Thank you very much. I knocked it out. Hopefully you knocked it out too. Good work, everybody. Fix your paper if you didn't get it right. And so you submit it for another grade for your quiz corrections. Take care.